So you got to solve for x. You need to undo first the minus 8, so let's plus 8, but you need to add 8 to each of the middle, the left, and the right. So if you add 8 to each side, on the left you've got 4, then you got less than or equal to 2x, less than or equal to 20. Undo the times 2, divide 2, you got to divide this by 2, divide this by 2. So you're going to have 2 is less than or equal to x less than or equal to 10. But let's back up, because this is what you've got to remember. What if it was not 2x? What if it was a negative 2x? Yeah. If this was a negative 2x, if you had to divide by a negative 2 and you had to divide this by a negative 2 and divide this by a negative 2, then you've got to change the direction of your inequality. Anytime you multiply or divide by a negative, you've got to change the direction of your inequality. And that's the most important thing you got to remember. If you plug in if you don't know how to do it, you can plug in the answers and work your way back. So if you have no idea how to do it, you start with A. Try A. Let's say x is negative 2. What is a negative 2 plus 5? What's the absolute value of 3? That's just 3. And then you got to times it by 2. What's 3 times 2? They want you to end up at negative 6. So A is out, right? If A is out, so is B. So now you've got a 50-50. Try C or try D. So multiple choice are sweet because you can use your street smarts. You don't need book smarts all the time. Just try your answers and see which one works. Let's try 2. What's 2 plus 5? What's the absolute value of 7? What's 7 times 2? Is it a negative 6? So it's gotta be D. But why is it no solution? Because absolute value is distance, and your distance can never ever describe a negative number. It's always got to describe a positive number. You guys try 3. Okay, if they want not real, they want to know which ones are imaginary. So imaginary, pi is a real number, so anything with 1 you got to cross out. So now you got a 50-50 shot, so it's got to be B or C. 2 definitely is imaginary because there's an I, so your only answer is B, because that's the only one that's got a 2. But this guy is also imaginary. 2 and 3, square root of any negative is going to be imaginary. Okay, this review, this is only for the honors classes, so if you regular kids are watching this, you got the wrong one. Okay, when you multiply, you got to do the distributive property. You got to multiply both terms. So 3 times 4 is going to give you 12. 3 times minus I is minus 3i. And then you do the same thing with the 2i. 2i times 4 is 8i, and then 2i times a negative I is a negative 2i squared. You can combine these two terms. So now you're at 12 plus 5i minus 2i squared. And the number one thing you need to know about imaginaries is just an imaginary comes from the square root of a negative. But if you have I times I, if you've got I squared, that's actually a real number. It's a negative 1. So anytime you come across an I squared, you need to swap it out right here for a negative 1. So this is a negative 2 times a negative 1, which is a positive 2. Now the positive 2 and the positive 12 are like terms, so you got 14 plus 5i. Okay, now here's what you've really got to be prepared to do for the test. On your maps test, this might show up. What if you have I to the 37? Okay, I to the 37 is either going to be A, 1, B, negative 1, C, I, or D, negative I. So which of those 4 is it going to be? How many I squareds are there? Because all you think You just got to think in terms of I squared. You know I squared is a negative 1. So how many I squareds are in 37? So let's rewrite it. Let's write I squared to the 18. So how many are 18 squares? Is that 36? So we need to end up at 37. So here's the remainder 1. I to the 1. Change this. This is a negative 1. What is a negative 1 times itself over and over 18 times? Positive 1 or negative 1? It's positive 1 because it's an even amount. So what's a positive 1 times this I left over? Your answer is just I. So they're pretty easy, but you got to remember to think in terms of I squared. Let's do a couple more.
Would it be negative 1? Because wouldn't it be 8 if it times itself evenly? Then they'll cancel out.
Whoops, times I. So you have this I squared. That's a negative 1, right?
Yeah,
So negative 1 times itself, negative 1 times a negative 1, 18 times. That's going to end up being a positive 1. So positive 1, but then you got to times this 1 remainder. So it's just going to be I. Let's do another one. What if you have I to the 84? Okay, how many squares are in there? How many squares are in 84? So I squared to the 42. So I squared, trade I squared, trade it for negative 1. What's a negative 1 times itself 42 times? That's a positive 1. What if this was 86? So then it would be 43. So then it'd be a negative 1 times itself an odd amount. So then it would be a negative 1. Okay, let's do one more. What about if you have I to the 501? If you got a 501 I's, where are you going to end up at? How many squares are in there? I squared 250 of them, and then there's 1 remainder. So if you have I squared, if you've got a negative 1 250 times, is that a negative 1 or a positive 1? That's a positive 1 times I, so you're still ending up at I. Okay, try 5. Okay, subtract just means that you're going to take your first group, 10 minus 2i, and you got to subtract the 4, but then you got to subtract the negative 3i, and that's the same as adding 3i. So you should end up with 6 plus 1i. Next one, what about 6? Okay, now look, this is your giveaway right there. If you are subtracting 2 logs, but they've got to be in the same base, which they are, log base 2, log base 2. Subtraction, if you want to rewrite those as 1 log, subtraction is linked with division. So you can kill A and B. It's got to be either C or D because those are the only 2 that are using division. So, move number 1. I'm going to take this 5 and put it as an exponent. So log base 2 of x minus 1 to the 5th is the exact same thing as 5 times the log base 2 of x minus 1. And this is the same as x squared cubed is the same as x2 times 3. When you're taking a power of a power, you multiply the exponents. And when you're taking log of a power, you multiply that exponent. So you bring that exponent, bring it out to the front, and then you multiply it. So it's 5 times. Okay, now, so I've got this. I've got 5. No. We got log base 2 of x minus 1 to the 5th. Take away, I'm going to do the same thing. take away log base 2 of x to the 4th. And now the subtract is going to lead to division. So I'm going to go log base 2. My numerator is the first one, x minus 1 to the 5th, divided by x to the 4th. This 4 is going to be put as an exponent to that x. So that's why it's got to match up. This one's got to match up with D. Okay, so here's your street smarts. If you have access to a calculator, you can say let a equal 2, let x equal 4. But you have to have access to a calculator. If you don't, then you have to know the properties. So we'll go both ways. If you got a calculator, if a calculator pulls up on your screen, so let's go log base 2 of 4 squared, right? This is 16. So on your calculator, I'm going to go log, push log of 16. Now I'm going to do comma 2. So I'm taking the log of 16 and base 2, press enter. So my answer is going to be 4. Now I just go through A, B, C, and D and see which ones. So A, so look at A right here. But you've got to always keep your A as 2 and your X as 4. So on A, if you punch in log in base 2 of 2 times 4, you do 8. No, let's see. What do we want? Log base 2 of 8. So now you're going to go log of 8 above 7. You got to push comma. Here's your base. I'm taking the log of 8, but I want to do it in base 2. So you do comma 2.
So of 8 would be the big number?
Yep. This 2 is my little base. Your base has to come last.
What was X? That's X.
What was X? X was 4. Okay, on these calculators, if you go math, everybody press math. If you go down to, there's a template, but I'm not sure if the calculator pulls up on your computer will have the same template. It's A. So log base right there. It'll pull up the template so you can go log base 2 of 8. But that's the same way as writing it above how we did it. But I don't know if this shows up on your calculator, if it will have that template. So anyway, street smarts. You just choose a number for A and X, and if you keep that constant on each of the 4, you plug them in until you find out which one's going to match up. But now, here we go. Here's what you need to know. There's 2 types of common logs. The very, very, very most common log that we do is log in base 10. Base 10 is our number system. Our number system revolves around base 10. Scientific notation is all base 10. So probably the most common log you're going to see is in base 10. Log in base 10 of 100 is the exact same thing as log of 100. So Tyler, if they do not tell you what base they are in, it's because it's the most common base, and it's understood if there's not a base, you're in base 10. Okay? The other common log is in log base E. Okay, now E is actually a number. Look on your calculator. E, right above divide, if you go second divide, E is 2.7182818281828. So E is a number, kind of like pi. Pi is a number. So E shows up from these logs and these powers. E is used quite a bit in the world of finance and in the world of scientific. E is right above divide.
It is divide.
Okay, now E, log and base E is called the natural log. The natural log is the same as this, ln. So if you have ln of 4, that is the exact same thing as log base E of 4. So there's two things you got to remember. If they do not specify the base, it's base 10. That's our most common logarithm, base 10. But our natural log is log and base E. That's ln of 4 equals log base E of 4. So now, check this out. If you have got log base A of x squared, you can change it to be any base you want. If I want to change it to be the most common base, I want this. I want log base 10 of x squared divided by log base 10 of A.
Why of A? Why base 10 of A?
So if I've got log base 2 of 4 and I want to change it to be log in base 10 because I don't like base 2, I go log base 10 of 4 divided by log base 10 of 2. So if you want to change the base, you have got to rewrite it as a fraction, and you write it log whatever base you want. I could do base 100, I could do base 1000, but this one is your numerator and this one is your denominator. So this guy matches up with, what was the answer for this one? C. So they're changing them both to log base 10, base 10.
Why'd you put 100?
Okay, a to the x equals y. So if you've got a power and you want to go to a log, the morph is pretty slick. You just go log. This will always be your base, and then the y and the x. So if we've got 2 to the third equals 8 and you want to see that as a log, it's going to be log base 2 of 8 is 3. Number 9, send this one in. ln of x equals y. Okay, this is the natural log. The natural log is the same as log in base E of x equals y. So if you morph it to a power, E is going to be my base, y is going to be my exponent, and it's got to equal x. So it's got to be b. This one you could totally do Streetsmarts. So you go through your answers and you can multiply it forward to see which one gives you 2x squared plus 7x minus 15. But look at this last number. How do you get the negative 15? You times the last two together, right? So you can kill A, that's going to give you positive 15. You can kill B, that's going to give you positive 15. C could work, and D cannot, so it's got to be C. But if you've got 2x squared plus 7x minus 15, here's how we did it back in October. If this does not start with 1, it's going to be a little bit beastly. What is 2 times a negative 15? A negative 30. So you keep this 2x squared, you keep this as negative 15, but you're going to split this up into two pieces. Tyler, you got to stop talking. But they've got to add and give you negative 30. Or no, they've got to add and give you 7x, but they've got to multiply and give you a negative 30. So what's going to times and give you 7x, but add and give you negative 30? (10x) minus 3x. So you can only trade a 7x for a 7x, and 10x minus 3x is 7x. But 10x times a minus 3, there's your minus 30. So they've got to multiply and give you the first times the last, but they got to add and give you the middle. And now you do grouping. So I'm going to group the 2x squared plus 10x. What do they have in common? Divide them both by 2x. So it's going to be 2x times x plus 5. And then group these two. What's a negative 3x minus 15? What do they have in common? Divide these by a negative 3. So it's going to be x plus 5. And now what does this group and this group have in common? Divide them by an x plus 5. So it's going to be x plus 5 times 3x minus 3. There's somewhere we messed up. Should be 2x. Where did we get 2x? Where is it? Because it should be C, but we did not get C. We got almost C. This guy right here needs to be a 2. Right here? Oh, this is a 2. But it looks like a 3. Oh, nice. Okay, so we're good. 2x minus 3. Just sloppy writing. What about 11? If it starts with 1, the chances of it being pretty slick are quite a bit better. So we're going to try and factor it. Rewrite it as a times problem. And it's going to be x and x. That's going to give you your x squared. What's going to times and give you 12? But add and give you a negative 7x. It's got to be 3 and 4, both positive, both negative, or you got one of each. They both have to be negative, because they got to times and give you a positive. So then if they do multiply and give you 0, x has to be either a positive 3 or a positive 4. So it's got to be D. But try this one, try 12. Solve for x. Subtract 8, x squared is a negative 8. Undo the square, square root this, square root this. X is going to be square root of a negative 8. So it's going to be an imaginary square root of 8. The square root of any negative is going to be imaginary. 8 is the same thing as the square root of 4 times the square root of 2. So it's going to be imaginary times 2 times the square root of 2. Or it's going to be 2 imaginaries times the square root of 2. But we forgot to do the plus or minus at the very first. Plus or minus, plus or minus, plus or minus. So your answer's got to be plus or minus 2y times the square root of 2. No, it stopped marking them. So this guy is kind of the same thing. Can you rewrite it as the multiplication problem? Can you multiply two numbers and have them be a 5, but add them and end up at a negative 2? If you can't, that means your answer is not going to be clean. It's not going to be easy. It's probably going to be a fraction or a square root or some imaginary. So if that's not going to work, you've got to use the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So a is going to be 1. A is the number of your quadratic. B is going to be a negative 2. and c is the number of the constant, the 5, all by itself. So it's going to be x equals 2 plus or minus the square root of 4 minus 4 times 1 times 5 all over 2. So underneath the radical, that's going to simplify and give you a minus 16. So that's going to be some kind of imaginary. It's going to be 2 plus or minus I square root of 16 over 2. Square root of 16 is nice. That's a perfect square. So now you got 2 plus or minus 4i all over 2. Divide both those by 2 and you should have 1 plus or minus 2i. So you should have ended up on B. Okay, the key word right here is unicircle. Unicircle, if we put a circle in our coordinate plane, a unit circle is going to have radius of how big? Radius is 1, and it does not matter where the radius is, but do you remember, you always make a bow tie. So if you have a circle with the radius of 1, so check this out. Now I'm going to put that in the coordinate plane. So if we go right here and I make a 90-degree triangle, if I make my little bow tie, here's the sliver you're looking from. You're looking from right here. So one of these sides is going to be side X and one of them is going to be side Y. Which one's side X, which one's side Y?
Side X is on the bottom.
Side X is your X-axis. Side Y is going to be your vertical piece. So they want you to do tangent. Tangent is opposite over hypotenuse. So if you're looking from right here, opposite is going to be Y. Hypotenuse is 1. So tangent is going to, no, it's not opposite over hypotenuse.
No, it's opposite over adjacent.
Idiot, it's opposite over adjacent. Opposite over adjacent.
We all just sit here and let it make
Yeah, no kidding. So it's going to be Y over X. Opposite over adjacent, so it's got to be B. So now if you know how to do that, do 15.
She's like, oh, that's cool. It's like,
Cosine is adjacent over hypotenuse. So if you've got a circle, your unicircle, your radius is going to be 1. That's always the hypotenuse. So if I make my bow tie go straight up, there's my 90 degree. That's always the hypotenuse. This is going to be X. This is going to be Y. The sliver you look from is right here. So adjacent is going to be side X. Hypotenuse is 1. You should have put D.
oh my god.
Okay, that's it for part 1. Now you got to finish and watch part 2. Algebra 2 review part 2.